students, welcome back to today's Vidyanagar online science class. I'm here with you to continue our physics chapter, Force and Laws of Motion. Today we are going to discuss about very important point of this chapter, law of conservation of momentum. So in today's class we will discuss about law of conservation of momentum in detail. Okay, let's begin our today's class. So before describing about the law of conservation of momentum, first you have to know what is momentum. What is momentum? Momentum is the product of mass and velocity. Momentum is the product of mass and velocity, and which letter you can use to denote the momentum? P, which means P equal to me. P equal to mv. So what is momentum? Momentum is the product of mass and velocity, and momentum P equal to mass into velocity, that is P equal to mv. Okay, and now we are going to discuss about law of conservation of momentum in detail. Okay, for that we have to discuss about an activity. Before describing about its statement, first we have to express the law of conservation of momentum mathematically. So first we are going to make the equation for the law of conservation of momentum. Later we will state the law. Okay, so look at the screen or look at the picture displayed on the screen. There you can see two balls A and B of mass ma and mb moves with the velocities ua and ub. Two balls A and B of masses ma and mb moves in the same direction with the velocities, with their initial velocities ua and ub. So the initial velocity of ball A, u, a, and the initial velocity of ball B, u, b, and their masses ma and mb. So two balls A and B with their masses ma and mb moves in the same direction with their initial velocities ua and ub. Okay, you can see this in the figure. Two balls A, B with the mass ma and mb moves with the same direction with their initial velocities ua and ub. Okay, after some time these two balls collide. After some times these two balls collide means they contact, they touch between each other. So after some time the ball A and ball B collide each other. When they collide each other, there exert which law? That is Newton's third law. When these two balls are in contact, there you can apply Newton's third law of motion, that is, for every action there is equal and opposite reaction. To every action there is equal and opposite reaction. If two balls A and B collide each other, ball A exert force on ball B and ball B exert force on ball A. So ball A exert force on ball B, that is FAB. What is FAB? Two balls A and B with their initial velocities ua and ub. After some time these two balls collide each other. These two balls collide each other, which means ball A exert force on ball B and ball B exert force on ball A. So if A exert force on ball B, that is FAB. Ball A exert force on ball B. At the same time, ball B exert force on A. Their magnitude same, but the direction is opposite. So in opposite direction. Ball A exert force on ball B, that is FAB, and B exert force on A, that is FBA. Okay, then after the collision, these two balls moves with their velocities. These two balls moves with their final velocities VA and VB. So this is about the activity. Two balls A and B with the masses MA and MB moves in the same direction with their initial velocities UA and UB. Okay, after some time these two balls collide each other. When these two balls collide each other, A exert force on B and B exert force on A. A exert force on B is FAB and B exert force on A is FBA. FAB and FBA are equal in magnitude but they differs in direction. So FAB exert force to forward direction and FBA exert force to backward direction. So ball A exert force on B and B exert force on A. Okay, after the collision, these two balls A and B moves with their final velocities VA and VB. So they have same mass, and after the collision, the velocity changed to VA and VB, and before the collision, so this is, you know what is this? Before collision. Before collision. Before collision, and this is after collision. After collision. Collision means joining. Okay, so this is, this is collision. Okay, so this part is before collision and this part is after collision. So before collision, the balls A and B with their velocities UA and UB, and after the collision their velocity changed to VA and VB. Okay, two balls A and B with their masses MA and MB moves with their initial velocities UA and UB, and after some time these two balls collide each other, which means A exert force on B, that is FAB, and B exert force on A, that is FBA. Then after the collision, these balls moves with their final velocities VA and VB. Okay, so before collision, velocities UA and UB, and after collision, velocities VA and VB. Okay, so this is about the activity. Two balls A and B moves with their initial velocities UA and UB. After collision, then after some time they collide each other, and collide each other means ball A exert force on B and B exert force on A, that is FAB and FBA. Then after the collision, these balls moves with their final velocities VA and VB. Okay, two balls A and B moves with their initial velocities UA and UB. Then after some time these two balls collide each other, and on collision A exert force on B and B exert force on A, that is FAB and FBA. After the collision, these two balls moves with their final velocities VA and VB, which means before collision the velocity was UA and UB, and after collision the velocity changed to VA and VB, and this velocity will be helpful to derive the equation. Okay, so before the velocities UA and UB, and after collision the velocity changed to VA and VB. And is there any change in the mass? No, same objects, right? Same balls. So till starting to ending, same balls. So there is no change in the mass. So before collision MA and MB, and after collision also the masses MA and MB. Only the changes in their velocities. Before collision it was UA and UB, and after collision it is VA and VB, but there is no change in the mass. After collision and before collision, the object is same, so they have same mass. But the velocity UA changed to VA and UB changed to VB. Okay. So two balls A and B moves with their velocities UA and UB, and after the collision, the velocity changed to VA and VB. Okay. So now we are moving to a derivation. Okay. So I told you the equation for the momentum P equal to MV, which is the equation for momentum MV. So first we have to find the equations for initial momentum and final momentum. Initial momentum and final momentum, or initial momentum or final momentum, or momentum after collision or before collision. Momentum after collision or before collision. So how to write the momentum before collision? So P before. So how to write the momentum before collision? So momentum of ball A. Okay. Momentum of ball A before collision equals to MA UA. Okay. So momentum, P means momentum. So momentum before collision of ball A. So the momentum of ball A before collision equal to mass of ball A, ma. And which is the velocity here before collision? Before collision the velocity is UA, initial velocity. Before collision, which is the velocity? Initial velocity. So initial velocity of ball A. Then momentum of ball B before collision equal to MB UB. Okay. Then the momentum of ball after collision. Momentum of ball A after collision equal to MA. After collision, the velocity U changed to V. So MAVA. And momentum of ball B after collision equal to MBVB. So UB changed to VB. Okay. So momentum of ball A before collision equal to MAUA. Momentum of ball B before collision equal to MBUB. And momentum of ball A after collision equal to MAVA. There the initial velocity changed to final velocity. And momentum of ball B after collision equal to MBVB. Now we have to find the rate of change of momentum of ball A. Rate of change of momentum of ball A means on collision ball A exert force on ball B, right? So rate of change of momentum of ball A means the ball A exert force on ball B. So the rate of change of momentum of ball A means FAB. So what is this? Rate of change of momentum of ball A. Rate of change of momentum of ball A means ball A exert force on ball B. So how to write the equation? You know, F equal to MA. F equal to MA. Here instead of A you can use V minus U by T. So just like if A exert force on B, how to write mass MA? Then instead of B, VA UA by T. So if ball A exert force on B, if ball A exert force on B means MA. So there if A exert force on B means there the important factor is ball A. Ball A is exerting force on ball B. So you have to write the force in terms of A. So here you have to write because A is exerting force on B. A is exerting force on B, right? Ball A is exerting force on B. So you have to write the equation for ball A. So if rate of change of momentum of ball B, rate of change of momentum of ball B means ball B exert force on A. Ball B exert force on A. So there you have to write the equation for ball B. How? MB into VB minus UB in by T. Okay. So rate of change of momentum of ball A equal to A means ball B exert rate of change of momentum of ball means ball B exert force on A. Ball B exert force on A, that is MB into VB minus UB by T. Here rate of change of momentum of ball A, which means ball A exert force on B. So you have to write the equation for A. Here B is exerting force on A. So you have to write the equation for B. Why you have to write the equation for A here? Because ball A is exerting force on B. So you have to write the equation for ball A. And if B is exerting force on A, then you have to write the equation for ball B. MB equal to VB minus UB by T. Then you apply the third law of motion. What is third law of motion? According to third law, FAB equal to minus FBA. So third law of motion states that if A exert force on B, B also exert force on A, but the direction is opposite. This is A exert force on B, that is equal to B exert force on A, but it is in opposite direction. So this negative sign indicates opposite direction. Okay, then apply FAB. What is FAB? FAB means MA into VA minus UA by T. Okay, equal to minus FBA MB into VB minus UB by T. FAB equal to minus FBA. FAB equal to minus FBA. So FAB MA into VA minus UA by T. FBA means minus into MB into VB minus U by T. So according to third law, FAB equal to minus FBA. FAB equal to MA into VA minus UA by T equal to minus into MB into VB minus UB by T. Then expansion. See, okay, first cancel this T and T you can cancel. Then expand the bracket. MA into VA, MA, VA. Then MA into UA minus MA into UA. Here it is minus UA. So MA into minus UA minus MA UA equal to whole minus there. Then MB into VB, MB, VB minus MB into UB, MB, UB. Then multiply with this minus. So MA, VA minus MA, UA equal to minus into MB, VB minus MB, VB minus into minus plus MB, UB. Okay, so from here you have to cancel the T and expand the bracket. MA into VA, MA, VA, MA into minus UA minus MA, UA equal to minus outside the bracket. Then MB into VB, MB, VB minus MB into UB, MB, UB. Then MA, VA minus MA, UA. Then multiply with this minus. Minus into MB, VB minus MB, VB minus into minus plus MB, UB. Then the thing you have to do, you have to write the U terms together and V terms together. You have to write the U terms and V terms separately. For example, see, this is MA and VA. Okay, so MA and VA. So I am going to take the VA terms to this side. So here I'll get the MBVB. So minus MBVB, if it is coming opposite of the equal to, then already MA, VA already here. Then I am taking this MBVB to this side. This is minus MBVB. So minus MBVB if coming to the opposite side plus MBVB equal to MBUB is already here. So now I have to take this MAUA minus MAUA on coming to opposite side plus. So MAUA plus MBUB. So this is the mathematical representation of law of conservation of momentum. See, at last what I done? See, I grouped the U terms and V terms. Now you can see here all U terms, MAUA and MAUB. MAUA and MAUB, and this is V terms, VA and VB. So now I grouped the final velocity terms and initial velocity terms. This is initial velocity terms, MAUA plus MBUB, and this is final velocity, MAVA and MAVB. So finally I need to group the V terms and U terms. So U terms here and V terms here. Okay. So I started from here. First we have to make the equation for momenta or momentum. If we are writing it singular, separate, you can use momentum, or if you are using their plurals, that is momenta. If you are writing initial momentum and final moment or momentum after collision or before collision together, so you have to use the momentum. There you are using two momentums, right? So plural of momenta, momentum, momenta. Plural of momentum, momenta. So here I can use momentum. Why? Because I am using this separate. Okay. So before collision of ball A, MA, UA. Before collision of ball B, MB, UB. Because before collision velocity is UA and UB. Mass, momentum equal to mass into velocity. So before collision the velocity is UA and here the velocity is UB. And after collision MA, VA and MB, VB. Because after the collision velocity, initial velocity UA changed to VA and UB changed to VB. Okay. Then rate of change of momentum of ball A. Rate of change of momentum of ball A means A exert force on B. If A exert force on B, you have to write the equation for ball A. If A exert force on B, you have to write the equation for ball A. That is MA. What is the equation for force? MA. But here instead of writing A as A, you can write V minus U by T. So here the V is VA minus UA by T because we are writing the equation for ball A. And FBA, rate of change of momentum B. FBA, which means ball B exert force on A. So MB into VB minus UB. Then you can apply the third law. FAB equal to minus BA. To every action there is equal and opposite reaction. Their magnitude are same but the opposite direction. So FAB equal to minus FBA. Then substitute. FAB equal to MA into VA minus UA by T. MA into VA minus UA by T equal to FBA minus into MB into VB minus UB by T. T cancel. Expansion of the bracket. MA into UA, MA UA, MA into minus UA minus MA UA equal to minus outside. MB into VB, MB VB and MB into minus UB minus MB UB. Then multiply with the minus MA UA minus MA, MA VA minus MA UA minus into MB VB minus MB VB minus into minus plus MB UB. Then finally group the U terms and V terms separately. So this is the V terms, MA VA plus MB VB. So for that already MA VA here. So I took the minus MB VB to the opposite side. If minus MB VB to the opposite side plus MB VB and MB UB is already here. So MA UA if coming to the opposite side minus MA UA plus MA UA. So the mathematical representation of law of conservation of momentum, MA UA plus MB VB equal to MA VA plus MB VB equal to MA UA plus MB UA. That means, so how we make a statement for this? So the mathematical representation is MA VA plus MB VB equal to MA UA plus MB VB. If you are writing first MA UA plus MB VB, then MA VA plus MB VB both same. Okay. If you are writing the U terms first or if you are writing the V terms first, both are same. Okay. So law of conservation of momentum states that sum of momentas of two objects before collision is equal to after collision provided there is no external unbalanced force act on them. So you can see here sum MAUA plus MBUB and MAVA plus MBVB. So the law of conservation of momentum states that sum of momenta of two objects before collision is equal to sum of momenta of two objects after collision provided there is no external unbalanced force act on them. So law of conservation of momentum states that sum of momenta of two objects before collision is equal to after collision provided there is no external unbalanced force act on them. So law of conservation of momentum states that sum of momenta of two objects before collision is equal to after collision provided there is no external force act on them. Sum of momenta of two objects before collision is equal to after collision provided there is no external unbalanced force act on them. Okay, so that's all about today's class. So this is the end of the chapter. force and laws of motion. We will meet you in another class with a new topic. Till then, it's bye. Thank you for watching. Have a great day ahead.